Good morning, dear students. In yesterday period, we were discussed about one example concern registers in series. Afterward, registers of parallel, definition of registers of parallel. Then, when two or more resistors are connected simultaneously between 2 points each other, then they are said to be connected in parallel combination. And parallel combination circuit diagram and equation. Finally, know the equation 1 upon r is equal to 1 upon r1 plus 1 upon r2 plus 1 upon r3, and some important points regarding parallel combination of resistors. It means the reciprocal of equivalent resistance is equal to sum of the reciprocal of individual resistances, and the potential difference across each resistor is same. Afterward, applications of parallel combination in daily life, and one solved problem on registers of parallel combination. Today, let us see heating effect of electric current. Yes, my dear students, a cell or a battery is the source of electrical energy. Due to the chemical reaction inside them, a potential difference is set up which is responsible for the flow of current through any circuit. Yes, my dear students, first of all, main sources of electrical energy is nothing but a cell or battery. Here chemical reaction takes place inside them, a potential difference is set up. So, maintain this flow, the source continuously has to provide the energy, but only a part of this energy helps in maintaining the current consumed into useful work. Rest of it may be expiated in the heat by raising the temperature of the appliances. Yes, my dear students, it means small amount of heat is what often expiated when the raising of temperature of electrical appliances. Therefore, when an electric current is passed through a high resistance wire like nichrome wire, then the wire becomes very hot and produces heat. In purely resistivity circuit, the source of energy continuously get dissipated entirely in the form of heat. This is called heating effect of current. Yes, what is meant by heating effect of current? Yes, my dear students, the resistivity or resistive circuits, the resistive circuits, the source of energy energy continuously gets dissipated entirely in the form of heat. This is called heating effect of electric current. Yes, second, listen here. The resistivity circuit, the source of energy continuously gets dissipated entirely in the form of water, in the form of heat. Yes, in the form of heat. This is called heating effect of electric current. This is obtained by transformation of electrical energy into heat energy. What happened here? Transformation process is takes place. Transformation from electrical energy into electrical energy into heat energy. Heat energy. Yes, this is termed as, my dear students, what a heating effect of electric current. Yes, examples are electric heater and electric iron. Yes, both are termed as what they function with the help of heating effect of electric current. Yes, my dear students, after discussing about heating effect of electric current, next discussion point is calculation of heat generated in a conductor. Calculation of heat generated in a conductor. Yes. Assuming a conductor as a resistance wire which resists the flow of current through it. So, work must be done by the current source for continuous flow of current. Now, we calculate the work done by the source when the current I flows through a wire of resistance R. When an electric charge Q moves against a potential difference V, then yes. Now we calculate the work done by the source when the current I flows through a wire of resistance R. When an electric charge Q moves against a potential difference V. Yes, potential difference V. Then just observe here, my dear students, assuming here we calculate the work done by the source when current I flows through a wire of resistance R. when an electric charge q moves against a potential difference v, then amount of work done amount of work done W is equal to q into v. It means charge into potential difference. Yes, it is equation number 1. Okay. From definition current, we know that I is equal to, from definition current we know that what I is equal to q divided by t, or q is equal to I into t. It is the equation number 2. From Ohm's law, V by I is equal to R, or V is equal to I into R. It is the equation number 3. Yes, equation number 3. Yes, my dear students, observe here. The amount of work done W is equal to Q into V. It means charge into potential difference. Current I is equal to Q divided by T. It means charge divided by time. R. Q is equal to current into time. From Ohm's law, V divided by I is equal to R, or V is equal to I into R. Substituting the values of the values of q and v in equation first. We get W is equal to in bracket I into T. It means charge into T into charge into resistance. T is equal to I square R T. I into I square and R T. Okay. Therefore, W is equal to, work done is equal to I square R T. Yes, my dear students, assuming that all electrical work done or electrical energy consumed is converted into heat energy, that is heat produced. So, heat produced is given by heat produced is given by H is equal to I square into R into T. Yes, heat produced is given by here I square into R into T. Yes, my dear students. Thus, it is called, or it is known as Joule's law of heating. This is known as what? Joule's law of heating. It is known as Joule's law of heating. Yes, H is equal to I square into R into T. Yes, my dear students, what it implies? This law implies first directly proportional to the square of current for a given resistance. What? Directly proportional to the square of current for a given resistance. Second, directly proportional to resistance for a given current. Yes, directly proportional to what? Resistance in a given current. Third, directly proportional to the time for which the current flows through the resistor. Yes, my dear students, first of all, H is directly proportional to current. Okay, square of current for a given resistance. S. Second one, directly proportional to, H is directly proportional to what? Resistance for a given current. Third, directly proportional to time. It is directly proportional to what? Time. Yes, this is known as what? Joule's law of heating, known as Joule's law of heating. Joule's law of heating. Yes, my dear students, after knowing about calculation of heat generated in a conductor or heating effect of electric current, let us discuss one solved problem given in our textbook. Example, an electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate and 360 watt when the heating is at the minimum. The voltage is 220 volt. And what are the current and the resistance in each case. Yes. Question: an electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate and 360 watt when the heating is at the minimum. The voltage is 220 volt. What are the current and resistance in each case? Yes, my students. Solution: yes, we know that power input is P is equal to V into I. Thus current I is equal to P divided by V. Okay, first question: when heating is at maximum, heating is at maximum rate, I is equal to P divided by V. It means 840 divided by 840 volt divided by 220 volt. Yes, 0 get cancelled, 11 za 40, 2 za 11 za 42 za 42 11. Yes, 11 3 za 33 33 90. Yes, it's a 88 88 okay. Answer is 3.82 ampere. 3.82 ampere. Yes, my dear students, same. And the resistance of the electric iron is, the resistance of electric iron is, the resistance of electric iron is R is equal to V by I. Yes, given data are 220 volt divided by 3.82. 3.82. Yes, 220 into 100 divided by 382. Yes, 191. Yes, it is equal to 191. Pfizer T5 955 955 1450. Okay, 7 za 1337 0 0 1 30 point 988 7.5. It is equal to 57.5 ohm. Yes, B1. When heating is at minimum rate, when heating is at minimum rate. I is equal to 360 divided by 220. Yes, after cancellation answer is 1.64 ampere, and the resistance of electric iron is R is equal to V by I. It means 220 volt divided by 1.64. Yes, the answer is 134.15 ohm. 134.15 ohm. Yes, my dear students, after discussing and solve problem, let us see our next discussion point: practical applications of heating effect of electric current. Heating effect of electric current. Heating effect of electric current. Yes, although heating effect of electric current causes undesirable loss of electrical energy, still there are some useful applications of it. Some of them are: first one is electric bulb. Yes, it is a filament made of tungsten. Yes, first of all, it is made of what? Tungsten. So most of the power consumed by this is dissipated in the form of heat, and some part is converted into light. Yes, what I found here, heat as well as light, both energies are formed, but content less is heat. It means light energy is largely produced here, because it has high resistivity and high melting point. Tungsten has what? A high melting point, high resistivity and high melting point. The filament is thermally isolated and the bulb is filled with chemical inactive nitrogen. Yes, the bulb is filled with inactive nitrogen and argon gas. Nitrogen and argon gas. Yes, my dear students, see here. First of all, electric bulb filament is made of a tungsten. So most of the power consumed by this is dissipated in the form of heat, and some part is converted into light, because it has high resistivity and high melting point. The filament is thermally isolated and bulb is filled with two gases. Yes, which gases? Nitrogen as well as argon gas, and they prolong the life of a filament. Yes, next point is electric fuse. Second one is electric fuse. It is used as a safety device in household circuit. It protects the circuit by stopping the flow of any unduly high electric current. It is connected in series with the main supply. It consists of an alloy of lead and tin. It consists of what? Alloy like lead and tin. Yes, the main purpose is safety device where in household circuits. Yes, When the current flowing through the circuit exceeds the safe limit, the temperature of fuse wire increases. The fuse wire melts and breaks the circuit. Yes, my dear students, temperature is increased where are exceed, where in a circuit. What happened? Fuse wire increase, the fuse wire melt and breaks the circuit. It means entire supply of electric current is stopped. This helps to protect the other circuit element from hazard caused by heavy current. Fuses are always rated for different current values such as fuse rating 1 ampere, 2 ampere, 5 ampere, 10 ampere and 15 ampere. Yes, my dear students. Next discussion point is electric power. Electric power. Electric power. Yes, it is defined as the amount of electric energy consumed in a circuit per unit time. Yes, my dear students, electric power, it is defined as the amount of electric energy, the amount of electric energy consumed in a circuit per unit time. Yes, if W be the amount of electric energy consumed in a circuit in t second, then the electric power is given by P is equal to W divided by T. Yes, but W is equal to electric energy, it is nothing but V into I into T. Therefore, according to Ohm's law, V is equal to I into R. Yes, P is equal to IR into I. It is nothing but I square R. Okay. P is equal to I square R. T is equal to V square divided by R. Yes, putting I is equal to V by R. Yes, my dear students, the SI unit of electric power is watt. SI unit of electric power is watt. It is expressed capital letter W. Yes. Solved example. Let us see one solved example. An electric bulb is connected to a 220 volt generator. The current is 0.50 ampere. What is the power of the bulb? Yes, Solution. First observe question. An electric bulb is connected to a 220 volt generator. The current is 0.50 ampere. What is the power of the bulb? Given data are here, my dear students. V is equal to 220 volt. Yes, and I current is equal to 0.50 ampere. Yes, what is the formula here? P is equal to V into I. T is equal to 220 into 0.50. Yes, is equal to 110. 110 joule per second or 110 watt. Power is here 110 watt. Yes. In this chapter, we all are discussed what is meant by electricity, electric charge, electric current, resistivity, insulator, alloys, connection in series, resistors of parallel, and some concern examples. Finally, heating effect of electric current and calculation of heating effect or heat generated in a conductor. It means H is equal to I square R into T. Finally, practical applications of heating effect of electric current. It means electric bulb as well as electric fuse, and the definition of electric power and one solved problem. Thank you. Thank you once again.